So as promised, today, I said you get to take that quiz home and finish it up. Do anybody have any questions on any of the stuff on the quiz, by the way? Pretty well good? Okay. So as promised, today we're going to talk about oblique triangles. And our oblique triangles are triangles that don't have right angles in them. So dealing with oblique triangles, we need to look at a couple of basic rules for triangles. And the first one, I'm just going to label this ABC. I've discussed this a little bit already. The angles are labeled with capital letters. The sides then are labeled with small letters and labeled according to the angle that it is across from. So this side over here is going to be which one? Little a. Over here, little b, and down here, little c. The largest side is across from the largest angle. So if I label these angles, 48 degrees, 76 degrees. First of all, what's angle C got to be up here then? $56, right? Because they have to add up to 180. What's that? That's not oblique. Well, it is oblique. There's no right angle in it. It's not obtuse. Oblique just means no right angle. Which side here has to be the largest? Little b has to be the largest side because it is across from the largest angle. Which side has to be the smallest? Little a is across from the smallest angle. Well, there is a law that describes this relationship. It is the law of sines. And what it states is, yes, the biggest side is opposite the biggest angle, but it's not a linear relationship. It's not related to the degrees of the angle, it's related to the sine of the angle. So for example, the length of side A divided by the sine of angle A would be equivalent to, have the same value as the length of side B divided by the sine of angle B, which would also be equivalent to the length of side C divided by the sine of angle C. That value, the length of the side divided by the sine of its opposite angle, is a constant for the triangle. Now that's only within that triangle itself. If you go to a different triangle, it's going to be a different constant. So what that means, if I give you a triangle here where I have some pieces given, let's say that's 68 degrees, this one's 49 degrees. And let's tell you that C is 51 inches. First of all, can I find angle B? Yes, how big does angle B have to be? 63, how'd you get that? Perfect, 180 minus 68 and then minus 49. There's 63 left over to add up to 180. Now we have all three angles and we have one side. Now the key is, do we have any sides and its opposite angle? Well, yeah, if we have all three angles, one of them has to be opposite the 51-inch side, right? What angle is opposite the 51 inches? 68. So that means we're going to have 51 inches. I'm going to leave the inches off. I'm going to leave the labels off just to make it simpler. 51 over the sine of 68 degrees. Which side do we want to find next? Pick one, A or B? A. A is going to go over the sine of which angle? 49 degrees. So to find A, we're going to cross, multiply, and divide. We have to make sure on our calculator that we close our parentheses on our trig functions. So it'll be 51 times the sine of 49, closing our parentheses, divided by the sine of 68. And again, close that parenthesis. We get 41.53. So A is 41.53 inches. To find side B, it's the exact same process. It's still 51 over the sine of 68 degrees. We can still use that one. I avoid using this 41.53 because I just calculated it. And even if I did do it correctly, there's still round off errors in it. So it's nice to go back to original information. What's going to go in the second ratio this time? B over sine of 63 degrees. So cross multiply and divide. Sounds about right. 49.01. Let's see if I come up with the same. You got her, 49.01. Good job. So B here is 49.01 inches. Now let's use what we just talked about up above there to make sure that this makes sense. The longest side is the 51. Is that across from the biggest angle? Yes, it is. The shortest side is the 41. Is that across from the smallest angle? Yes, it is. So at least that part of it makes sense. That doesn't guarantee that we're right, but it does stop us from making some really stupid mistakes. Now in this case, we had two angles and one side. And the one side happened to be across from one of the given angles. We could have two angles in one side in a different form, like this. We have 71 degrees, 39 degrees, and let's give you that this side over here is 50 feet. Do I have a side and its opposite angle here? Well, given, no, I don't, but I can find it, can't I? Because I can find this angle up here by doing what? Yeah, from 180, which gives us 70 degrees, perfect. Now we have a side in the opposite angle. Which side? Well, we only have the 50 foot. What's its opposite angle? 70. 50 over sine of 70. Let's do A first. A will be over the sine of 39. Anybody have any questions as to where I'm getting this proportion from? You're confused, Jasper, or just in pain? Okay. Cross multiply and divide. 50 times sine of 39, close that parentheses, divided by the sine of 70. 33.49. That's going to be feet. Now we're going to do the same thing to find B. 50 over the sine of 70 equals B over the sine of 71. What do we expect B to do here? What value do we expect it to have? Bigger or smaller than 50? Bigger, but just barely, right? So 50 times sine of 71, make sure you close the parentheses, divided by sine of 70, 50.31. So that's 50.31 feet. And again, smallest side is opposite the smallest angle. Biggest side is opposite the biggest angle. So this law of sines is relatively easy to use when we have two angles and a side. I'm going to have you guys try one. Yeah, that one sucks. Let me try that again. There. I'm going to give you this angle here, 122 degrees. This one up here, 21 degrees. And we'll call this side over here 123 feet. Find the missing sides and the missing angles. I'll give you a couple minutes. So we can find the angle there, 37 degrees. The 123 is going to go over what? Sine of 122 degrees. Let's find side A first. What goes below it? Sine of 37 degrees. So we're going to do 123 times sine of 37 divided by sine of 122. That's going to work. 123 times sine of 37. I forgot to close my parentheses. That's what was going to work. Divided by the sine of 122. 87.29. So 87.29 feet. Do we expect C to be longer or shorter? Shorter, smaller angle across from it. So let's do it. 123 over sine of 122 equals B over the sine of 21. 123 times sine of 21, close parentheses, divided by sine of 122. 51.98. How many of you had that? Okay. Now, it becomes a little bit trickier when we are given two sides and one angle. So we're going to look here at two possible cases. The first case is the easy case. The side opposite the angle is the larger side. What do I mean by that? Well, let me give you some numbers here. I'm just going to list it this way. If I tell you that angle A is 40 degrees and that side A is 50 feet and side B is 30 feet. Notice the side that is opposite the angle, the 50, is the longer of the two sides. So that means there's only one possible solution here. Here's my 40 degrees right here. The opposite side over here is 50. This side is going to be 30 feet. This side over here is going to be 50 feet. That's the only possible triangle I can make here. So this was A, this is little a, this is going to be little b, so this will have to be big B, big C, little c. Does that make sense? So now I can find angle B here by having 50 over sine of 40 equals what? 30 over sine of B. Now note here, when I cross multiply and divide, I am not going to be finding angle B, I'm going to be finding the sine of angle B. So I'm going to do sine of 40, close my parentheses, times 30 divided by 50. I get 0.3857. That is the sine of angle B. Angle B is going to be the inverse sine of 0.3857. So I leave that in my calculator so I don't have to punch it in. I do second sign, second answer. So I'll take the inverse sign of that previous answer. 22.69. So this is 22.69 degrees, making this 117.31 degrees. How did I get 117.31? Subtracted from 360. Very good. Now from there, I've got this angle. So I've got my 50 over the sine of 40 equals C. Now I do have to use an angle I've calculated. There's no way around it here. 117 over sine of 31, C over the sine of 117.31. I'm going to trust you guys can handle that part. So I'm going to give you guys another one to try. If I tell you that angle B is 30 degrees, side B is 45 feet, and side C is 40 feet. Find the rest of the pieces of that triangle. I'll give you, hey, look at this problem. So here we're going to look at angle B here is 30 degrees. This is going to be angle A and angle C here. So side B is 45. Side C is 40. So this will be little b, little c, little a. So now again, because that opposite side is the longer of the two sides, there's no problem here. So we've got 45 over sine of 30 equals 40 over the sine of what? C. So we cross multiply and divide. Sine of 30 times 45, or times 40 divided by 45 is 4.444, or 0.44444. So C is going to be the inverse sine of 0.44444. Second sign, second answer. C is 26.39 degrees. We knew it had to be smaller than 30, right? So that makes this one 123.61. Obviously not drawn to scale. Yes, that would be obtuse. So A then, A over the sine of 123.61. Well, that would be the 45 over sine of 30 yet. So 45 times the sine of 123.61 divided by the sine of 30. 74.95. So it's relatively easy when that's the case. The difficulties come when we have two sides and one angle, and the opposite side is shorter. Let me show you. Let's say A is 30 degrees. We don't know B and C. Let's take side little a to be 40 feet, side little b to be 50 feet. We don't know side C. So here's angle A, 30 degrees, right? I'll make that a little less tight. The opposite, I'm just going to label this A, B, C. This over here is 50 feet. This side over here is 40 feet. It could look like that, but there's another way it could look. I put the 40 feet right here. Still fits, doesn't it? Because that side's shorter, it can buckle back in like that, and it's still going to fit in there. We don't know which of those two options it's going to be. If I tell you that B is an acute angle, what's that tell us? It's the brown option. Yes, not the blue. So let's calculate it that way. 40 over the sine of 30 degrees equals 50 over the sine of B. Cross, multiply, and divide. Sine of 30 times 50 divided by 40. 0.625. So B is the inverse sine of 0.625. 38.68 degrees. Which makes this 111.32 degrees, correct? And you can find side C down here. So what if I told you that B is obtuse? Well, here's the problem with that. When I set this up, it's still 40 over the sine of 30, isn't it? Equals 30 over the sine of B. When I cross multiply and divide, I still get sine of B is 0.625. That's what I had up here. If I do the inverse sine of 0.625, I'm still going to get 38.68. You said the key word over there, reference angle. In my unit circle, there are two angles that have that sine of 0.625. One of them is right here, the 38.68. The other one is over here. It has a reference angle of 38.68. What's the actual angle? 141.32. Where'd that come from? 180 minus that. The supplement. Supplementary angles have the same sign. So the supplement of that would be the 141.32 degrees, which of course leaves this one as being 8.6, not 88, 8.68 degrees is all that's going to be. Does that make sense? So if I don't have a picture that shows that angle is clearly obtuse or clearly acute, we have to be told that that angle is acute or obtuse. Otherwise, it's indeterminate. You can't tell which answer is correct. I would never do that to you where I didn't give you one or the other. So obviously this angle here is obtuse, right? So if I give you this angle here is 41 degrees, this side here being 51 feet, this side over here being 72 feet. Find angles B and C inside little c. I'll give you some time to work on. Okay, so we have a side in its opposite angle, which would be what? 51 over the sine of 41. And then, of course, we got 72 over the sine of B. Cross multiply and divide. Sine of 41 times 72 divided by 51, 0.9262. We do the inverse sine. We get 67.85. Now, to get the actual angle, we would do the supplement of that, which is going to be 112.15, correct? How many of you had that, 112.15? Anybody not sure where that came from? No, we took what we got from the inverse sine, we subtracted from 180. Because on that circle, that sine of 0.92, there's an angle here that's the 67.85. That's what the calculator always gives you, is that acute angle, but this is an obtuse angle. Well, there's an obtuse angle here that also has that same sine. It has a reference angle of 67.85. The size of the actual angle is the supplement of that. The calculator will never give you an obtuse angle for an inverse sine. So if it's an obtuse angle, you have to do the supplement of what the calculator gives you. There's another case that we can run into. Contain your excitement. Where we have an angle, one angle and two sides, but neither of those sides is opposite the angle. Can we use the law of sines here? For the law of sines, we have to have a side and its opposite angle. Is there any way we can get a side and its opposite angle here? Not with what we know so far. On Tuesday, we will talk about something called the law of cosines. The law of cosines applies when you have two sides and an angle. This is called the included angle. It's the angle between the two sides. So when you have two sides and the included angle, how do you find the third side so that you can then use the law of sines? For now, in your book, page 781, exercise 36-8, and page 784, exercise 36-9. Do 1 through 11 the odds. So it's only 12 total problems. Suggest you do a good share of them because this does get a little complex. And people struggle with this one on the quizzes. Well, the law of sines is all this assignment's about. On Tuesday, we'll talk about law of cosine.